Alrighty, so question 13, chapter 17b. Let's look at number F, or part question F. Okay, so we have the curve y is equal to x squared take x cubed. Now, we want to find when the gradient is equal to -1. So when we have just a regular curve, what that tells us coordinates. It doesn't tell us anything about the gradient. So to find information about the gradient, we need to differentiate this. So we use the dy on dx notation. And then we bring the power down the front, so it'll be 2x, and then we drop the power by 1. Same thing, bring the power down the front, so 3x, then we drop the power by 1. So it'll be 2x minus 3x squared. Okay. Now they want us to find when the gradient is equal to -1. Now remember, this is just telling us the gradient of the curve. So it's the gradient of this little friend here. So what we can do is we can go, alright, well, we want to find the gradient when it's -1. We go, well, when is 2x take 3x squared equal to -1? That'll give us the x coordinate. Alright, if we actually look over, we'll come back to this in a sec. If we look over here, so this is the gradient function that we've just found, 2x minus 3x squared. We want to find when the gradient is equal to -1. So we could actually just graph this, which is what I've done here. And then if we want to find where it's equal to -1, what we can do is we can go, alright, well, -1. Okay, so it's at this x value here, so we can see it's going to be -1 twice, and it'll be probably at about 1, and then also this little one here, if I can actually draw it correctly. So it's about a -1/3. So the original curve we have, its gradient, we can graph the gradient curve, and we can see that it's actually going to be -1, the gradient's going to be -1 at 2 x values. And that'll probably be around about x equals 1 and around about x is equal to -1/2. Anyway, we don't need to actually do this to solve the question, but it is good to keep in mind that we can graph all of the algebra we're doing. Alright, so we're back here. We've got the algebra expression, 2x minus 3x squared is equal to -1. So we're trying to find those red lines. What we do is we go, well, try and get all the expressions on one side. Because when you have a squared, we know how to do quadratic formula or factorize. We can solve them pretty easily. I'll get the leading term first because that's what I'm most comfortable with. Great. And this is just a quadratic equation. So we can solve this. You can use quadratic formula, you can use factorization, guess, or your CAS. Now, what we'll get, whichever way you choose, you'll get 3x plus 1 in the first bracket, and the second bracket you'll get x minus 1 is equal to 0. Alright, then solve this, so you'll get 3x plus 1 is equal to 0, which will give you 3x is equal to -1, so x is equal to -1/3. And then here, x minus 1 is equal to 0, so x is equal to 1. And that's kind of what we saw on the graph before. And then to find the y coordinates, we just sub these back in to the original equation. Because remember, the original graph that gives us coordinate positions. So we'll get y is equal to 1 squared minus 1 cubed, which is equal to 0. So this coordinate here will be 1, 0. And then here we go, y is equal to negative 1, 3 squared minus 1 on 3 cubed. So that'll become 1 on 9 minus, and that'll be minus 1 on 27. So 3 on 27 plus 1 on 27, which is 4 on 27. So our second coordinate will be negative 1/3 and 4 on 27. Alright, so these will be our answers. And if we look over to if we look at this curve here, our original curve, and we look at it graphed, which I've done up here, you'll see, well, okay, at negative 1/3, which is around about here. So that tangent, well, that's going to have a gradient negative 1, and this is going to be the same as here. Obviously, not very accurate from my pictures, but I hope this helps.